All right, good morning, good afternoon. I hope you guys had a good spring break. I had an eventful spring break. If you haven't already, remember to write your last name first and then write your first name. And please put your class period and also put the color. Right now I'm recording in yellow class, so you could put like period 2 and then you could put yellow. Or you could write gold if you're confident in your class, because yellow and gold, I guess, is the same thing. All right, so every week I'm going to try to do this. I'm not making any promises, but I'm going to try to always print out your starters from this point forward. And I'm going to record a video, and I'm going to do Monday for you. And Tuesday, Wednesday, Thursday, Friday is going to be a version of what you saw on Monday to reinforce whatever it is that we're learning, relearning, or teaching, or I'm teaching you that week. So Monday number 1, Tuesday number 1, Wednesday number 1, Thursday number 1, Friday number 1 are all going to be similar, okay? It says convert from standard form to vertex form. And then it says hint, draw a square. So I'm only drawing the square because I think there's benefits to drawing the square. So I have 1x squared, so I'm going to write x squared. And then I have 6 x's. So what that means is I have 3 on the side of the square, and I have 3 on the other side of the square. And if you count those, you have 6 total, right? So the heading or the title would be x plus 3 and x plus 3, okay? And then I have 3 times 3. Can somebody tell me what 3 times 3 is? 9. So that means I have 9 constants in here. But if you look at your standard form, how many do you have? How many constants? 10. So how many are you missing? 1. So you need 1 extra. You know what? I keep writing in red, but it should be in blue. Okay? So you have 1 extra. So if I were writing this in vertex form, I would write it like this. I would look at my heading first. I have x plus 3 squared. So I have x plus 3 squared because I have a square. And then I have 1 constant on the outside plus 1. So that's the vertex form. Y equals x plus 3 squared plus 1. All right, so number 2, again, Monday number 2 is similar to Tuesday, Wednesday, Thursday, Friday, number 2. So it says, given the vertex form, find the standard form. Okay. So for this one, you have to know how to multiply binomials or polynomials. So what I'm talking about is this right here. This x minus 3 squared, you have to find this first and then add that 3 at the end. So I would build my square and I would write x minus 4 on the top and x minus 4 on the side. And then draw a 2 by 2 box so that you end up with 4 terms and then you simplify. So let's go ahead and start multiplying. So what's x times x?
X squared.
X squared, thank you. And then what is x times negative 4?
Negative 4x.
Negative 4x. They just get married. You just write them next to each other. So negative 4x. And it's the same down here. Negative 4 times x is negative 4x. And no, these do not cancel. Do you guys remember negative 4x plus negative 4x together is what? Negative 8x. So if we were going to write these two together, it would be negative 8x, right? Because they're like terms. But you can't take away x squared. Like you can't say, okay, I have 2x's here and I have 8x's here, so it's negative 6x. Because this is an exponent and this doesn't have an exponent. Well, it does. It's an exponent of 1. It does have an exponent. But do you guys understand that the exponent of 2 cannot be taken from something that has an exponent of 1? You can't subtract those. They're not like terms. So I get ahead. Negative 4 times negative 4. What is that?
16.
Positive 16. Thank you for saying positive. Positive 16. So now that we have all the terms inside of our square, we're going to extract it. Okay, we're going to take everything that's on the inside and take it out. So we have x squared minus 8x, because we already combined that. And then we have that plus 16. But don't forget this up here, that plus 3. So what's 16 plus 3? 19. So now let's rewrite this. So we have x squared minus, 8x plus 19. And we're done. So if you want to get a little ahead, you can move on. But if you want to see how I do letter B, this is how I would do this. So you have x plus 5 squared. I would handle this first and then this 3. Okay, don't forget the 3 and don't forget the minus 2. We're going to handle that at the end. So we have x plus 5 times x plus 5. So let's multiply everything there as well. And I'm going to zoom this in because I'm going to write kind of small. And I want you to write small too on your paper. So what's x times x? X squared. What's x times 5? And then what's x times 5?
5x.
And then what's 5 times 5? Okay, cool. Now let's take everything that's inside and write it outside. So I have x squared. And then how many x's do I have? 10. And then how many constants do I have? 25. Okay, so this just got rewritten to that. Now I'm going to multiply by 3, and then I'm going to subtract by 2. So let's put the parentheses, and put the 3 outside, and put the minus 2 outside as well. Now, do you remember the order of PEMDAS? Do you agree that you should multiply? You need to multiply before you subtract? So let's multiply. Let's multiply first. So you're going to multiply everything, all those terms. 3 times x squared, 3 times 10x, 3 times 25. Okay? Now, 3 times x squared?
3x.
3x squared. 3 times 10x?
30x.
30x. 3 times 25?
75.
75. And then you have that
Subtract 2.
minus 2. And then that minus 2 can only be combined with the 75. So what is it?
73.
73. So let's rewrite it. 3x squared plus 30x plus 73. That is my final answer. So if you already did this before this video, just, make sure you got it right. And don't be lazy. Draw out the box because you're probably going to need it at some point Tuesday, Wednesday, Thursday, or Friday. You probably are. All right, so there's multiple ways that you can go about graphing this parabola on number 3. I'm going to show you the way I do it, but there's many ways to Grandma's house, right? Like there's other ways that you can graph this. So first, I noticed that this form is not in standard form. What form is given to you?
Vertex.
It's in vertex form. So because it's in vertex form, I can already tell you what the vertex is.
-2,
So it's going to be, the vertex is -2,
-1.
-1. So I'm going to go to -2, -1, and I'm going to drop my vertex there. And because I know that the vertex is here, I also know what my axis of symmetry is. Do you guys remember what the axis of symmetry is?
No.
The line in the middle. Thank you so much, Kevin. Yeah, and that's x equals -2, which is this number right here. So I'm going to also draw my axis of symmetry, and I expect all of you to draw the axis of symmetry. So draw the axis of symmetry. So what that tells me is that the parabola is going to have a reflective property on the vertex and on the axis of symmetry. Okay, so if you notice, there's no a value. There is an a value. What's the a value here? 1. So that means it's positive and it's going to open up, right? So if you remember how Miss Martinez taught this, and if you remember how Mr. O'Cleary taught this, I didn't teach you this, but they did teach you this. When the a value is 1, from the vertex, you could just go right 1, up 1, and drop a point.
Yeah.
Right 1, up 1. Left 1, up 1. And then you go right 2, up 4. 1, 2, 3, 4. Left 2, 1, 2, up 4. 1, 2, 3, 4. Drop a point there. And then if you go over 3, 1, 2, 3, how many do you go up? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Same over here. And there's your parabola. So you can do it that way.
Wait, we got to do 3 points.
I would say do as many points as you can on the graph. So sometimes it'll be like 3, 4, 5. Just do as many as you can. There's a parabola. Okay? Another way you can do this is a X and Y plane. Sorry, X and Y chart. And remember what Miss Yanis taught us? Where would we put the vertex in our graph? In the middle. So let's put our vertex here, and then we're going to put our vertex right here. -2, -1. Okay? And then you count 2 points to the left. So if you're on -2, what's the next number to the left? -3, and then -4, right? And then 2 points to the right, which are -1 and 0. And remember, because this is the axis of symmetry or the line, so that means it's a reflection. So whatever number you get here is going to be the same number you get here. And whatever number you get for -4 is the same number you were to get for 0. So this is another way you can do this. You can plug in 0 to your equation because 0 is easy to compute. So let's plug in 0 mentally. 0 plus 2 is what?
2.
2. Now what's 2 squared?
4.
What's 4 minus 1?
3.
3. So let's put 3 here and 3 up here. And then we're going to see if it matches our first method.
No.
Now let's plug in -3.
-1.
You want to plug in -1 instead?
Yeah.
You guys prefer -1 over -3? Okay, let's do -1. So let's plug in -1 mentally. What's -1 plus 2?
1.
1. Just 1.
Squared.
What's 1 squared?
1.
What's 1 minus 1?
0.
0. So if you put 0 here, you put 0 here. Okay, now let's see if these points match up. This is our vertex. Do we have a point at -3, 0? Yep. Do we have a point at -1, 0? Yep. Do we have a point at 0, 3? Let's see, 0, 3. Yep. Do we have a point at -4, 3?
No.
Yeah, right there. So this method matches our other method. But remember, the first method is only possible when you have an a value of 1 or -1, because you could just do it on the opposite side.